Hi all, welcome to Maths Explanation for You. Today we are trying to explain this problem. Show that every positive even integer is of the form 2q and every positive odd integer is of the form 2q plus 1, where q is some integer. So to show this, we use Euclid's division lemma. Euclid's division lemma. What is it? So here you can see a dividend 39 is divided by a divisor b, which is equal to 6. If you divide this 39 with 6, you will get a quotient of 6, because 6 times 6 is 36, which is less than 39. Okay, so 6 times it will go inside 39 and you will get a quotient 6, and 36 when subtracted from 39 will result in a remainder of 3. So Euclid's division lemma says that if you divide any number a with another number b, you will get a quotient and a remainder. And these four values or four terms are related as dividend is equal to quotient multiplied by divisor plus remainder. That means this 39 will be equal to 6 times 6, or 6 multiplied by 6 plus 3. 6 36, 36 plus 3 39. So that kind of a relation is existing between quotient, divisor, dividend, remainder. Okay, so dividend is equal to quotient into divisor, or quotient multiplied by divisor plus remainder. So just substitute the symbols. We get a is equal to q multiplied by b plus r, or simply we can say a is equal to bq plus 6. A is equal to bq plus 6. Now we assume that a be any positive integer, that means any integer which is greater than 0, and we assume that b, the divisor, is equal to 2. Okay, we assume divisor is equal to 2. Then applying this Euclid's division lemma, or Euclid's division relation, we get that a is equal to, we know already the relation a is equal to bq plus r. So here we are going to substitute b. So instead of b, we will substitute 2. Then we will get a is equal to 2q plus r. A is equal to 2q plus r. But we know that the remainder will be always less than the divisor. The remainder should be always less than the divisor. And we also know that the remainder will be always greater than 0. Remainder can be 0 and greater than 0. That means remainder is always greater than or equal to 0. But the remainder cannot go beyond the divisor value. So here the divisor is 2. So the remainder r should not be greater than 2. That is, r should be less than 2, and it should be also greater than or equal to 0. So 0 greater than or equal to r greater than 2. That kind of a relation can be formed. So once again I repeat, Euclid's division lemma gives a relation between quotient, divisor, dividend, remainder. The relation is nothing but a is equal to bq plus r. So where b is the divisor, q is the quotient, a is the dividend, and r is the remainder. We know that the remainder will be always less than the divisor and always greater than or equal to 0. So when we substitute the divisor b is equal to 2, we get a is equal to 2q plus r, where r is the remainder, which is always less than or equal to, always less than 2, which is always greater than or equal to 0. So we can say that a is equal to 2q plus r, where 0 greater than or equal to r greater than 2. But we also know that the remainder is always an integer. Remainder should be an integer since we are doing division. So only r can have integer values. We know that if it is less than 2, then remainder can be either 0 or 1. There is no other possibilities, because between 0 and 2 there is only one integer, which is 1, and the another one which is neither positive nor negative, it is none other than 0. So r can take two values, 0 or 1. So remainder can be either 0 or remainder can be either 1. We can substitute these values in the equation a is equal to 2q plus r. Okay, so r will have two values, r is equal to 0 or r is equal to 1. We are going to substitute these values of r in the equation a is equal to 2q plus r. Okay, so when we substitute r is equal to 0, we get a is equal to 2q. Okay, if we substitute r is equal to 1, then we get a is equal to 2q plus 1. Okay, so instead of r, if you substitute 0, you will get a is equal to 2q, and instead of r, if you substitute 1, you will get a is equal to 2q plus 1. But we already said a is any integer. A can be any integer, a positive or means even number or odd number, anything. Any positive integer can be any positive integer. But we know that since q is also an integer, 2 times q, 2q will be always an even number, right? Yes, if any integer multiplied by 2 will always result in an even integer number. So a is equal to 2q is always an even integer. Then definitely a is equal to 2q plus 1 will always be an odd number. So in general we can say that to represent any odd integer, we can use the term 2q plus 1, since 2q will be even, and if you add 1, it will always be odd number. So 2q plus 1 can be used for general representation of an odd integer. Okay, thank you. So if you have any questions which need to be explained in detail, you can send that question to the email address provided in the description.